So in this video, we're going to actually use power series that we've already derived to come up with other power series. So we're going to focus on taking power series that we have and manipulating them and forming new power series. These are very common questions on the AP exam, both for the multiple choice and the free response questions. In our first example, we're going to use our power series for e to the x that we've already derived, and we're going to use it to find the power series for e to the 2x. So what you want to realize is that all we need to do is replace our x with a 2x in the power series that we already have. So if we have e to the x is 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus, and then so on. We could also go back and remember this was 1 over 0 factorial x to the 0 and 1 over 1 factorial x to the first. To get e to the 2x, we're just going to replace all of our x's with a 2x. So that would give me 1 plus 2x plus 1 over 2 factorial 2x squared plus 1 over 3 factorial 2x cubed plus 1 over 4 factorial 2x to the fourth. Since we're looking for the fourth degree power series, that's all we need to do for the first part of this. So that's going to be 1 plus 2x plus 1 over 2 factorial 4x squared plus 1 over 3 factorial 8x cubed, and all I'm doing here is just going ahead and expanding 2x and squaring everything and taking 2x and cubing everything, and then 1 over 4 factorial 16x to the fourth. Now what I want to do is change that over to sigma notation. So we're going to start with n equals 0 to infinity. And we'll notice, let's break this up into parts. So let's go back, and here for the 1, let's change that to 1 over 0 factorial x to the 0. We'll move this over a little, maybe not. We'll just rewrite this in front as 1 over 1 factorial and then 2x to the first. 1 over 2 factorial, and so on. So we notice that each one of these has a factorial. So it's going to be 1 over n factorial. So that takes care of all of our factorials. Then each one of them has, if I go back and look at the 2's, you've got 2 to the first. 4 is 2 squared. 8 is 2 cubed. 2 to the fourth. And then this would also be 2 to the 0. So then I would have 2 to the n, and then x to the n also, which if you look is the same thing as 2x to the n, which again, notice that that would be what I would get if I replace the x up here with the 2x. Now, there are going to be times you're going to want to write them like this. There's nothing wrong with writing the problem like this. You are allowed to write it as 2x to the n, but there'll be times where some stuff will cancel and simplify. And if you combine those as 2x all to the n, it may be hard to see the simplifications. So now let's look at one involving cosine. So again, we want to find the fourth degree power series and then the nth term power series. This time we're going to do x times the cosine of x. So let's start with what we know of cosine. So cosine of x is 1 minus 1 over 2 factorial x squared plus 1 over 4 factorial x to the fourth minus 1 over 6 factorial x to the sixth. Then what I want to do is I want to multiply all of that by x. So x cosine becomes x minus 1 over 2 factorial. Then this will be x cubed, because x times x squared would be x cubed. Then we'll have plus 1 over 4 factorial, x to the 5th. And I guess I should have been careful about this. You actually can't find a 4th degree power series. So we'll stop when we get to the 7th degree power series. And then this will be 1 over 6 factorial, x to the 7th. Then I want to find the nth term power series for this. So we'll do sigma n equals 0 to infinity. Let's write this as x to the 1st. And notice that if we go back and put a 1 over 0 factorial, that'll give me a pattern on my factorials. So now I've got 0 factorial, 2 factorial, 4 factorial, 6 factorial. So then I can make this 1 over 2n factorial. And then we have x to the, and notice that we've got odd powers here. We're increasing by 2, so it's 2x, and then it would be plus 1. And then we also have to make our signs alternate. So let's go back and squeeze in a negative 1 to the n, because negative 1 to the 0 would be 1, so I'd start with a positive number. And now that should be our general power series, or our nth term power series, for x times cosine x. So in our last example, we're going to take our power series for 1 over 1 minus x, and we're going to use it to come up with the power series for 1 over 1 minus x squared. And notice what I need to do is replace all my x's with an x squared, because that's the only difference in those two problems. So we'll start with the one that we've been given here. 1 over 1 minus x is 1 plus x squared plus x cubed, and so on. So 1 over 1 minus x squared would say replace every x with an x squared. So I get 1 plus x squared plus x squared squared plus x squared cubed, and so on. Now, I only want the 4th degree power series. So then if I put the 4th degree, that would be 1 plus x squared plus x to the 4th. Now, I am going to just go back, just so when I get ready to do my power series, my general power series, or my nth term, I'm going to recognize that that's x to the 0. So then this becomes sigma n equals 0 to infinity. And notice that we just have powers of x. We'd have x to the, well, these are all the even numbers. Even though I didn't use it, my next one here would have been x to the 6th. So these are all even numbers, so I know it has to be a 2n problem. And if I put in 0, I start with 0. When I let n be 1, I get x squared. Let n be 2, I'd get x to the 4th. So that would become my power series. Now, we can also look at if I had just replaced in my power series from my original power series all the x's, instead of having x to the n, if I replace that with x squared to the n, notice that that will simplify, because when I raise an exponent to another exponent, you multiply those, and so that would have become x to the 2n, which is what we had here. That's really all there is to taking power series and deriving them from other power, or using them to derive other power series. All right, so what I'm going to do is I'm going to give you a few problems that I want you to do for the next time that we're in class. All right, so here are the 5 problems that I want you to work on for tomorrow. Take our known power series for e to the x, 1 over 1 minus x, sine of x, and cosine of x, and derive each of the following. You have x squared sine of x, e to the x cubed, x over 1 minus x, and it's really important that you think of that as x times 1 over 1 minus x. Then x squared cosine of x, or x times the cosine of x squared, and 2x times the sine of e to the x.